Hello to all of you. This is Dr. Dhaval Maheta, and today we will understand how to run regression analysis using Python. Basically, we run regression analysis when we are having one dependent variable and many independent variables. So, we want to see the effect of these independent variables on explaining the dependent variables. So, how we can do this? Let's see in Python. So, first of all, I will activate some libraries like import pandas as PD, import numpy as np, from sklearn import linear model. Then I'll activate df. So my target variable is here price, which is continuous, age of the flat or age of the house, number of bedrooms, and the area. Now I want to consider price as a dependent variable and area, bedrooms, and age as independent variable. And I want to make a model which can predict the price on the basis of this. So first of all, I will import maths. Why it is necessary for me to import math is, you can see here there is a missing value and I want to replace this missing value. So I'll calculate the median of this bedroom. So median underscore bedroom is equal to math.floor df bedrooms dot median. Please find the median of this data. So it is 3. Now I'll replace this missing value with 3. So df.bedrooms is equal to df.bedrooms.fill now median bedrooms with median bedrooms. And now this nan will be replaced by, that is nan is no value available, will be replaced by the median. After that, I'll run the linear regression. So regression is equal to linear underscore model dot linear regression. Then I'll run regression dot fit df area bedrooms age df price. After that, I can find out the regression coefficient by reg.coefficient, and reg is the intercept. Now, instead of running all these commands one by one, you can also run the fit one summary command. So for that, you will have to activate the library from statsmodels.formula.api import OLS, ordinary least square. Regression 1 is equal to OLS. I'll specify the formula where price is a dependent variable and this is tilde. This is located below the escape button above the tab on your keyboard. So my dependent variable is dependent on the area of the house, the number of bedrooms in the house, and the age of the house. So when I'll run this, I'll get the output in this format. I will have to understand this output. First of all, you have to see the p-value of the individual coefficients. These values should be less than 0.05. So here we can see neither of them is neither of them is less than 0.05, and that means that these variables are not significant. This is first thing. The second thing which you should see is the p-value of overall model. So here also the p-value is more than 0.05, and therefore the overall model does not exist. Now, what are the null hypotheses for t-test and what is the null hypothesis of ANOVA? I am writing down. So the t-test, its null is individual coefficients are not significant for this one. The desirable is that your p-value should be less than 0.05 so that we can reject and we can see it that these variables are significant. ANOVA is, we run ANOVA for overall model. It means that area, bedrooms, and age overall, are they affecting the price or not? So here the null hypothesis is model does not exist, or in other words, jointly coefficients are not significant. The desirable is, in both the cases we reject null, and for that our p-value should be less than 0.05. But here in both the cases our p-value is more than 0.05. Now we can also, you can say, do trial and error, and first of all we will surrender those variables which are highly insignificant. So I'll remove age from here and we can see the results. Now you can see that the area has become significant. See, still bedrooms is insignificant. And overall model, the p-value of the overall model has also become significant. If I drop the bedrooms also, I'll get a very significant model. So you can see here 0.004, the p-value is less than 0.005. This is also less than 0.05, which means that overall model, the individual coefficients are significant, overall model is also significant. Now R square is the explanatory power of the model. Any value which is above 0.6 is considered to be the good model. So here the model is having a 95% explanatory power. It means that area of the house is able to explain the variation in the price 95% of the time. Quite good. So three things we have to say in regression analysis: individual coefficients, overall coefficient, overall p-value, and R square. So the p-value of individual coefficients, then this one, and then this one. Now, suppose we keep things as it is. And we try to make a model from this, right? So here, area, bedrooms, and age is there. So, if I want to predict that what will be my price if the area is 2600, number of bedroom is 3, and my age of the house is 20. So regression dot predict. So when I'll run it, I'll get the value 5,33,000. This is same as if I take the individual coefficients, that is 1.73. This is a constant which I consider here. Then 143.625 into area. So this is the area, 2600. 3 bedrooms, 3 bedrooms, and its coefficient minus 6762. Then 20 is the age of the house, so 20 into 337.5. So I'll get the same value from both the ways. So this is a way you can run regression analysis using Python. For more videos on data science using Python, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos which are related to data science using Python. Please don't forget to subscribe the channel and press the like button.